Hey, welcome back. We lost a half hour fighting test runners, but now we're just going to go and play with some JavaScript SVG so we end on a positive note. I'm still joined by Dr. Andrew Williams in Milwaukee, and let's go look at the code here. And in fact, let's draw a turtle. So the code that I have here, let's bring up the right project here. Yes, bring it back up. Yes, all this test runner stuff's not working. Okay, so the source code. The main.coffee is the main file which loads the modules and calls into them. The main thing it's using is this thing, reactive coffee, with the SVG support. I have my global object domain, which creates these worlds where you can get and set values. And then I have my drawing function, which takes the SVG context for rendering things on the browser, and then it calls this fairly complicated creature called drawGrid, which has now a fairly simple path for drawing the grid lines. So this creates an SVG path. Which will minimize you. This Genkov animation is my go-to. So Genkov SVG tutorial is my go-to place for SVG. And it's basically a series of commands. There's convenience functions for drawing circles and lines and rectangles, but the heart of it is this thing called a path. And this is what PostScript and PDF were based on. And what they do is they have a series of essentially really trivial little commands, which are nicely concise here. You can see the list of commands here. So move to a location, then move around. You can use absolute coordinates versus relative coordinates. You familiar with those terms, Andrew, in drawing? Or you can kind of guess what they mean. You can either move to a point on the screen or just move by distance. And they have basically a couple different versions of lines, a couple different versions of curves, and an elliptical arc, which actually might be an interesting one to try for our turtle. So what I did was I originally built this turtle that you see before you using an ellipse, a circle, and 4 legs. And one thing I realized is that actually it looks a little weird to have the legs on top of the body. It looks like he's lying on his back. Let me see if I can change this here. And then I go to my HTML page and reload it. Yes. Okay, that's progress. So you see how the elliptical thing is actually now on top of the legs instead of underneath them?
Yes.
Okay, so that's because I've changed the order of which these things are here. Now, it would be more elegant and also much more efficient to draw it as a single path command rather than as a series of primitives like this. So what I want to do is let's create a draw turtle path, which is a new version of this where we try to use a more elegant or at least more efficient SVG algorithms. So what I'll do is I'll just start here, and I'll do path equals m x comma y. And then this thing at the end will return s.path, so just and what was our green? So we're creating a draw turtle function, which takes kind of a XY index and then figures out how to draw that path. And then let's just do, to test it, a relative 100 v100. So it'll just draw a couple of lines at different locations, so it's less. And let's just see. First of all, does it build? Yes. And then can I refresh it? Okay, it hangs because what? Oh, grid path, yes. So the mistake of not. Wait, where's grid path? Why is it? An error there. Oh, did I delete something when I was doing it? Ah, yes, that would cause problems. So let's try that again. Draw turtle path is not there because I probably gave it a different name. No, I did not give it a different name. Okay. Try it one more time. Third time's the charm. Ba-doom! Yes! And it closes the path automatically and gives us that funky triangle. Okay, so. And this is the draw little path variant. So what we're going to do here is, now that we have a center point that we're starting from, I want to draw a circle. So let's try that first, the elliptical arc. So what we need is curve 2. Let's try curve it. There's lots of different curves. From point XY. Let's try curving to, let's see, width equals cell size divided by 2. That was a weird coloring artifact. And let's just try going there. And see what it does. It draws a straight line, which is not terribly
Can I ask
interesting.
a question?
Sure.
So you're going to build this whole game from these low-level commands?
So the goal is that I would build this is mostly just for me to get comfortable with drawing SVG, and the kids would be working at the higher levels where they are. Well, let's see, there's a couple different ideas I'm playing with here about where we can go with this. The simplest thing is I just keep drawing the turtles the way I'm drawing them, or I have someone else create a more elegant SVG drawing of a turtle than this one. The stretch goal is to say, how about these things are just strings? So these paths that I'm drawing are just strings which are part of the configuration. And that, in theory, people could hack their own SVG strings and draw them and add their own characters. So it wouldn't be part of the high-level programming interface, but it would be something that would be hackable and accessible for people who want to extend it without having to write actual code. So that the turtle, rather than being an embedded graphic file sitting on the server, is just another string that's passed into the HTML web application. So that would make it a little bit more flexible, both for people who want to hack it later, but also during testing and development. I can just be rapidly iterating on different SVG paths. So that's kind of the idea. And so this is not activity by itself isn't terribly useful, but it's a good way to just try and get more familiarity with the SVG and the different.
Okay, so a game like Minecraft, what do they use? Do they use?
Okay, a game like Minecraft is doing 3D drawing, which is a whole different universe. This is why I call this one Turtleverse 2D, because we're just doing really simple vector line graphics for this iteration. When you start talking 3D graphics, then you're talking OpenGL or equivalent, extremely CPU-intensive, extremely sophisticated graphics that you generally need experts to do for you.
Okay, so what are some examples that are similar to what you're trying to do using JavaScript to do animation? I'm just not familiar.
Sure, yeah. If you go into here, you can see, if you go to code.org actually and look at some of the existing hour of code videos, you can see most of that stuff runs in the browser. So these are the kinds of things that people are doing, and most of that stuff is stuff running in the browser. If you're interested in, there's quite a lot of animation you can do with JavaScript or CSS. So this is an example. You remember Street Fighter from your youth? So that kind of animation is very simple to do with JavaScript and CSS. Can you see that okay?
Yeah.
So depending on the platform you're running on and the complexity of your graphics, you can make it more or less sophisticated. So for the level we want, it's sufficient for our Turtleverse 2D first version. Does that answer your question?
Yeah, but you're not aiming for this level of graphics.
I'm not aiming for this level of realism. I'm aiming for more of an iconic minimalist feel. Although it is not inconceivable that, this is not that hard to do. You just need a really good artist, right? The actual animation behind the scenes is not that sophisticated. It's just, having the right series of images that you're drawing to convey the image of realism. And it's
I hear you.
So
do you have evidence that kids like JavaScript animation?
They don't know, right? So our baseline is, but this is not the game that we're going to sell for large amounts of money. This is the game we're giving away for free to teach programming. And so the level of the hour of code stuff, at least for last year, was is this. So this is the kind of, this is what my son did last year when he was 5 years old, right? Is these kinds of very simple minimalist graphics. So our goal is to have a better, have a comparable graphics quality to those things and a better programming experience.
Okay, so using something other than the blocks that you're just showing right now.
Right, yeah, trying to use this graphical interface that I'm hoping to develop. That would actually be another exercise, which we probably don't have time for now, would have been to stop worrying about the graphics and start working on the control structures, which I was hoping to do, but today is one of those days. So
All right.
Anyway, so let's see if I can figure out how to just to draw It's just modest goal. Try to draw a curve with our turtle path thing here. So let's see what the thing about drawing curves. One of the first things you talk about in graphics since in the PDF era is what's called a Bezier curve, where you have these lines and arcs. And radius of the arc, let's try and draw an arc. That's probably what we need to be able to do. So we go from the center, and we want to draw an arc to that distance away, relatively speaking. Then we go, okay, first radius of the arcs with the first two parameters, which is, let's just use the same numbers for those as our distance. Arcs in RY, the same direction will result in a circular arc. And then excess rotation, that's usually going to be 0. And then large arc flag and sweep flag. Basically inside and outside. Let's just go with 0, 1. And then the last 1, 2, 3, 4, 5, and 6, 7 is the destination. So let's see if, okay, we have an arc as such as it is, and which is not, and we probably want that to be filled. And comma there, I believe. And then we want to be able to draw it backward to make it look like a flipper. So let's just get this. And going back to where it came from. Let's see that. Yes, and that's a flipper of sorts. And,
nice.
And so we actually want to draw arc as it's going to Y, and sign, Y sign, and the return is let's do it like that. Do that, then do that. And let's try to make this so Start 1. Let me try that. Oops. Got a man there. That's not good. Oh, we forgot to put the width in. That would explain. JavaScript is not known for its brilliantly clear error messages, since it doesn't really care about a lot of things like arguments. Yes, okay, we got a little arc there. Let's save that. And then we can do yeah. These are actually flippers since we're now a sea turtle. Doesn't do anything yet. Just want to save it, make sure I didn't break anything, and then this becomes check that. And for our final feat, we could make this, yeah, let's make it more elegant. So for offset in there might be a more clever way to do this, but I'm not sure what that would be. Let's try it and see what happens. Woohoo! Birdie!
Yay.
There's probably a more elegant way to specify that, but it does work. And now, let's see if we're really bold, we can get our ellipse over that. And then, so let's say is m 0, no, m with 0, and then mountain arc. Let's just have to do that. Actually. I mean, not what we want, but let's just see what it looks like. Oops. Oh, right, we have to put the All right, that's going in the wrong direction. Like, let's just see what that does, actually. That's interesting. What we really want is actually 0. Can it do that? Actually, not bad. It's sort of getting there. Except that, actually, I think we want. Oops, that was weird. Oh, I need a reset. Did we not try that for this window? Oh, that's the problem. We have too many you have to keep these. This one, otherwise it becomes more complicated. And that was a little thin. But it's a start. So do 2 times. So that's what happens. So what I want would that's my destination. The other way around, we want it to be 2. There we go, getting closer between that then. It was 2/3. Oops, just a minus sign somewhere. Not bad. 30 seconds of JavaScript hackery. And I'm going to leave it at that, since I got to go pick up my daughter and run off to other things. Anyway, that gives you a sense of the sort of things that you can do with SVG, and then some of the now real people will actually use like Illustrator or something like that and generate SVG files after drawing it out freehand. This is really just a mental exercise, not necessarily all that valuable, except that it's good to get some idea of the low-level capabilities of the system. And then the theory is that once we do it like this, we can dynamically redraw these things as I change the position programmatically and get this guy to walk across there. And then, in theory, we could even make it do a little bit more fun, like wiggly animations as it walks and so forth. But that's a problem for another day. Thanks for joining me, Andrew. Thanks for all of you listening, and we'll see you next time. Goodbye!